There is an element that makes up the cheapest pencil in your school bag, and the exact same element that makes up the most expensive diamond ever sold at auction. Same atom, completely different price tag. Let's talk about carbon, element number 6. And here's something genuinely strange before we even get into the science. Nobody actually knows who discovered carbon, or when. There's no single name attached to it, no single triumphant lab moment. Why? Because humans have been using carbon since the very first person ever handled charcoal from a fire. It is one of the oldest materials in human history, used by literally every civilization that ever existed, and yet for thousands of years, absolutely nobody realized it was an element at all. The ancient Egyptians and Sumerians were using charcoal to extract metal from ore as far back as 3750 BC. Diamonds were already being discovered and treasured in China around 2500 BC. Soot, charcoal, coal, diamond. Humans had been using for wildly different-looking materials for thousands of years, completely unaware they were staring at the exact same chemical element the entire time. So how did we eventually figure that out? In 1772, French chemist Antoine Lavoisier ran an experiment that should sound almost too simple to matter. He burned a sample of charcoal, and separately, he burned an actual diamond. If these were two completely different substances, you'd expect two completely different results. Instead, neither sample produced any water at all, and both released the exact same amount of carbon dioxide gas per gram. Identical chemical fingerprint. From a piece of burnt wood, and from one of the rarest, most expensive gemstones on the planet. Then in 1779, graphite, the gray material inside your pencil, got burned in air and was shown to also produce carbon dioxide. Same fingerprint again. And finally, in 1786, French scientists confirmed graphite really was, fundamentally, the same element as diamond. Three wildly different materials. Soot, the hardest natural substance on Earth, and pencil lead. All proven, through fire, to be made of the exact same atom, arranged in three completely different structures. Lavoisier officially listed carbon as a recognized element in his 1789 textbook, giving a name to something humanity had been quietly using since prehistory. Here's the part that should genuinely blow your mind. The only difference between a worthless pencil and a multi-million-dollar diamond is how the carbon atoms are physically arranged. In graphite, carbon atoms form loose, flat, stacked sheets that slide easily over each other, which is exactly why graphite rubs off onto paper so easily when you write. In diamond, those same carbon atoms lock into an incredibly rigid three-dimensional lattice, making it the hardest naturally occurring substance known to science. Nothing was added. Nothing was removed. Just a different geometric arrangement of the exact same atom, and the result is the difference between trash and treasure. And carbon has even more disguises than that. In 1985, scientists Robert Curl, Harold Krodo, and Richard Smalley discovered a completely new form of carbon while running laboratory experiments meant to simulate the chemistry happening inside dying stars. They found carbon atoms spontaneously arranging themselves into hollow, spherical structures, shaped almost exactly like a soccer ball. They named it Buckminster Fullerene, after the architect famous for geodesic domes. This discovery was so significant it won the 1996 Nobel Prize in Chemistry. An entirely new form of one of the oldest known elements, discovered completely by accident, while trying to understand the atmosphere of stars. Now here's where carbon stops being interesting and starts being essential. Carbon is the literal foundation of every living thing on this planet. Every protein, every strand of DNA, every cell in your body is built around a carbon backbone. Roughly 18.5% of your entire body mass is carbon, making it the second most abundant element inside you, right after oxygen. You are quite literally a carbon-based life form, in the most scientifically precise sense of that phrase. And carbon has one more incredible trick. It can tell us how old something is, sometimes down to the century. Carbon exists in nature mainly as two stable isotopes, but there's a third, radioactive isotope called carbon-14, which decays at an extremely precise, predictable rate, with a half-life of about 5,700 years. Since living things constantly absorb carbon while they're alive, and stop absorbing it the moment they die, scientists can measure how much carbon-14 has decayed in an ancient object and calculate almost exactly how long ago it died. This technique is called radiocarbon dating, and it has settled some genuinely historic mysteries. When scientists tested the Dead Sea Scrolls, the dating confirmed they really were roughly 2,000 years old, validating their authenticity. But when scientists tested the Shroud of Turin, the cloth long claimed to have wrapped the body of Jesus Christ. Carbon dating revealed the fabric was actually created between 1260 and 1390 AD. Over 1,000 years too recent. One of history's most famous religious relics, quietly exposed by counting decaying carbon atoms. Let's go further. What if all the carbon on Earth disappeared right now? There would be no right now. There would be no Earth's surface as we recognize it. No plants. No animals. No humans. No DNA. Carbon isn't one ingredient among many for life. It is the ingredient. Every organic molecule that has ever existed, in every living thing across the entire history of this planet, is built on a carbon framework. Remove carbon, and you don't get a different version of Earth's biosphere. You get no biosphere at all. Beyond biology, every diamond, every pencil, every piece of coal, oil, and natural gas vanishes instantly, since they're all forms of carbon or carbon compounds. The entire fossil fuel industry disappears in an instant. Steel production collapses, since carbon is essential for turning iron into steel. Modern electronics lose graphene and carbon nanotubes, two of the most promising materials in cutting-edge technology research. It isn't an exaggeration to say a world without carbon isn't a harder world to live in. It's a world incapable of producing life in the first place. Quick round of facts about carbon that sound made up but are completely real. Fact 1. In 1955, scientists at General Electric successfully turned graphite into actual diamond using extreme heat and pressure in a laboratory, achieving artificially what nature normally takes billions of years of geological pressure to accomplish. Fact 2. Carbon can bond with itself and other elements to form more known compounds than every other element on the periodic table combined. Millions of carbon-based compounds have been identified, and new ones are discovered constantly, which is exactly why an entire branch of chemistry, organic chemistry, is dedicated almost entirely to studying this one element's compounds. Fact 3. And this one is genuinely strange. Diamonds are not actually rare in the way the marketing has convinced people they are. Their high price is largely controlled by a small number of major commercial suppliers managing global supply, not by genuine, extreme natural scarcity in the Earth's crust. So there it is. Carbon. Element number 6. Used by every human civilization in history before anyone knew it was a single element. Capable of forming the cheapest material on Earth and the most expensive material on Earth, using the exact same atom arranged two different ways. The literal chemical foundation of every living thing that has ever existed, and somehow still capable of quietly exposing thousand-year-old religious forgeries just by counting how much of it has decayed. Next time, nitrogen. The gas making up nearly 80% of the air you're breathing right now, completely invisible, completely silent, and somehow directly responsible for both feeding billions of people on Earth and powering some of the most destructive explosives ever created. See you there.